TOC stands for total organic carbon. Okay, TOC stands for total organic carbon. Okay, and so TOC can be separated into okay, TOD stands for total organic carbon. And TOD can be separated into oxidable and non-oxidable. And oxidable including the COD. Okay, COD means chemically oxidable carbon. Okay? And after that, we can separate into biologically degradable and not biologically degradable. And so BOD stands for the biodegradable carbon. Okay? And also you can separate BOD into hard BOD and soft BOD. So the hard BOD means the large molecules. So it might take hours, even days to degrade. And the smaller molecules for soft BOD, normally you just take up directly. Okay. So small BOD for some like sugars, like alcohol, okay, or some organic acid. And large BOD including like proteins, like fats, and some biopolymers. Okay. So the molecular mass is huge. So it might take up hours or even days to degrade. Okay? So the O here means, the total here means O. Okay, let's see these questions. Okay, ethanol. This is another name. This is a common name. Okay. Same. Ethanol, or ethyl alcohol, is used in beverage, wines, beers, or even as a gasoline additive and other industrial applications. Small amount of ethanol and also sugars are used in biological process to produce methanol. Both these compounds end up in the wastewaters, coming from facility which produce methanol. Okay. So the question asks you to calculate THOD demands for the wastewater company. Okay. So I give you 1 minute to do this question. Okay, finish. Let me do it, okay? So this question asks us to calculate THOD. So OD stands for oxygen demands, okay? OD stands for oxygen demand. What does that mean? This means the oxygen required to oxidize all the organic compound. Okay? So for question A asks us the ethanol. Okay, ethanol. So C2H5OH. And we also need to assume complete oxidations. So this is 3 and 2 CO2. Okay, and first off, let's find out the molecular weight of methanol. So it's 46. Okay, and we have a molecular weight of oxygen. It's going to be 32. And we have 3 more. We have 3 more, right? So it's going to be 3 times 32. 96. So we need 96 milligrams of oxygen. So the THOD, or the problem is we only got 25. Okay, we only got 25. So it's gonna be 25 times to 96 oxygen over 46 milligram of ethanol. Okay, this is a ratio. So we are going to have 52 milligram of oxygen over liters. Okay, everyone? So we like this. Okay, just the same things, right? Everyone okay? Okay, next one is glucose. Okay, stimulant. Okay, I will just show you the answer in my PowerPoint slides. But we have 45s instead of 25. So 45, and we have 6 more of oxygen here. So 192 comes from 6 times 32. Okay, so 6 times 32 over 180. 180 is the molecular weight of glucose. Okay, 48 times 192 over 180. So the THOD will be 48. 下次要带笔记来抄啦。你没书没东西都没有，你考试时候。So you remember you need to take notes, okay? During our exams, you can bring anything except electronic device, okay? But you can bring calculator. Understand? Any paper-based reference you can bring with you for your final exam, except like iPads, okay? But you can bring your calculator. Any question?
How about printouts?
Yeah, you can bring out. Okay, you can bring out. You can take notes. Okay, you can take notes. All right. So let's see next questions. So next question is the mixtures. I want to mention here the THOD can add up. So THOD total equals, in these questions, THOD ethanol plus THOD glucose. Understand? So THOD is linear. So you can add up linear. Understand? So question C is super easy. So we already found the answer for A and B, right? So it's the answer from A plus answer from B. That's it. So it's 52 plus 48. The answer is going to be 100 milligram oxygen per liter. Please write down. Okay? So just simply add up. Okay? So the next one is Henry's law. Henry's law is super important. Okay, Henry's law is super important in chemical engineering, in unit operations, right? So what does Henry's law means? So Henry's law means the amount of gas that dissolved in a liquid is proportional to the keyword here, please highlight, partial pressures. Okay, it's proportional to partial pressures. Okay, of the gas above the liquid. So the Ca here stands for concentration of A. The Cn stands for concentration of A. And the Kh is the equilibrium constant. Okay, often called Henry's law constant. And Pa stands for partial pressure. Partial pressures. So based on Henry's law, so if there is higher gas pressures, if there is higher gas pressure above the water, this means more gas dissolve. Based on this Henry's law. Okay? So actually, I want to put one word here. The Ca actually is dissolved. I want to put this word, may you understand this better. The Ca actually is dissolved concentrations. Okay, this is how much gas is actually dissolved in the waters. So the higher KH, we know KH is a constant. Okay, different solvent, different things, cannot have different KH value. So the higher KH means this gas is more soluble. Okay, the higher KH, the higher the Henry's law constant means this type of gas is more soluble. Okay? So as you can see here, the different gas, they're gonna have different KH value. And one thing I also, as you can see in Henry's law, you only got concentration, constant, and pressure, right? But I want to mention one thing here is actually temperature matters. So why temperature matters? Why temperature matters? Although we do not see any terms of temperatures in the Henry's law, but why temperature matters? Anyone? Okay, anyone? Nobody for gas, but not all the gas. For most gases, actually as temperature increase, I mean gases, okay, not solid, not liquids. For most gases, as temperature increase, solubility decrease. Okay, but not all the gases. I mean most gases. 大部分的气体那个温度增加，溶解度减少。Okay. In opposite, for most solid and liquids, as temperature increase, solubility increase. That's what we recognize, right? For gas and liquids. But the problem is, for gases, but most gases, not all the gases, as temperature increase, solubility decrease. So although we do not see any terms in the Henry's law, but actually temperature matters for the solubility of gases. Okay, so let's see these questions before we enter this class. Okay, this question is asking the solubility of oxygen in waters. Okay, the background is, so this is from our textbook. Okay, this question is from our textbook. Although the atmosphere we breathe is compressed of around 20.9% of oxygen. Oxygen is only slightly soluble in water. In addition, okay, everyone please highlight this. This is what I mentioned about. The solubility decreases as the temperature increases for oxygen. Okay? Thus, oxygen to the aquatic life decreases during the summer. Okay? So, in summer, the temperature is around 25 to 30. This is in the United States. In Taiwan, probably 30 to 35. Okay. Typically for many surface water in the United States. So Henry's law constant for oxygen at 5 degrees Celsius is 61.2. And it changed. It lowered to 40.2 when temperature increased to 25 degrees Celsius. So this question asks us to calculate the solubilities of oxygen at 5 degrees Celsius and 35. It's super easy. I will just give you 1 minute for this. Okay, that's it. Student, listen up. Okay, so based on formula C equal K times P, and K, different materials at different temperatures will have different K, okay? So in these questions, we are going to calculate the dissolved oxygens at 5 degrees Celsius and at 25 degrees Celsius. So it's super easy. 61.2 times, so 20.9%. Put that in 0.209. Okay, so it's around 12.8 milligram per liters. Okay, for at 25 degrees Celsius, it's going to be 40.2 times 0.209. So it's going to be 8.40 milligram per liter. So as you can see, the dissolved oxygens decrease as temperature increase, right? Okay? Okay? Before I let you go, I want to ask, okay, this calculation is super easy, but it got lots of meaning inside. Okay? So I got another questions. Why colder water holds more oxygen. So after you got the answers, just like when you do some experiments and you got a result, you need to explain it, right? So why colder waters hold more oxygen? Anyone? Anyone? Anyone want to share your thought? Anyone? Don't forget I have student list here. Okay. So as temperature increase, the gas molecules will have more kinetic energy, right? Okay, and this means those dissolved oxygens might leave water easily. Okay? As temperature increase, more the gas molecules will have more kinetic energy. So are we on the same page? You are always me, right? Okay, you might know this, right? The kinetic energy is equals 3/2 RT. So kinetic energy actually is proportional to temperature. You might learn this in general chemistry, right? Okay, so in this case, the equilibrium dissolve oxygen concentrations decreases. Okay, as temperature increase, the gas molecules has more kinetic energies, leading dissolved oxygen leave water easily. Okay, thus this should be like this as well. Let me change this to answer. Okay, as temperature increase, the gas molecules have more kinetic energies, and the dissolved oxygen leave water surface easily. In this case, the equivalence dissolved oxygen concentration decreases. Okay? Okay, then we still have 2 minutes. Okay, let me finish this. Okay, have you might see this Okay, you might see this in unit operation class, right? So this is called air stripping tower. Okay, air stripping tower. So air stripping tower is a treatment unit. Okay, often used in environmental engineering to remove volatile and semi-volatile organic compound from water. Okay, so this process works by transferring dissolved gases from water into air. Okay? Okay, we have one question here, but we will do that next time. Okay, I probably need to speed up. Okay, next class I will speed up, and we will introduce. And also I post another PowerPoint slides. Another PowerPoint slides here is about the review of biologists, but we will not go through all of it. I will just say something important. So next class we're gonna finish chapter 1 and chapter 2. Then we move on to the treatment of solid waste. Okay? So that's pretty much of today. And one question I would like to ask: who doesn't have glue? Please raise your hand. Who doesn't have glue? Please raise your hand. Please raise your hand if you do not have glue. Can you three glue? Raise your hand. Stand up, stand up. Who doesn't have glue? Please stand up. Stand up, please stand up. Who doesn't have glue? Please stand up. So you three have glue, is that okay? You three. Is that okay? You don't have glue, right? Do you have glue? 有，你有 glue 了。那你呢？我有啊。台湾人的 glue 站起来，台湾人的 glue 这两个台湾人，新台湾人。台湾人站起来，台湾人的 glue 站起来。台湾学生。台湾的。然后你们怎么 glue？ 你们怎么 glue？ 你们后面三个吗？你们后面三个 glue 吗？你们两个哦，可以叫他们两个吗？凑4个，可以做好一点。好，那你们两个一走了。OK， 那整。你们两个一走后面那两个同学。OK， that's for today. Thank you so much for coming.